Well, hello and welcome to my next video. I've added so many things I've actually lost count, so I've got a little list. Mostly just tightening code up, fixing things, but there are a few new features to discuss. So this is the latest build of the game. I'm going to click start and we'll get right into it. The first thing you might notice is there are bushes everywhere. I've increased the foliage count. Let's advance time a little bit. Yeah, they've got these nice high quality bushes. The movement is slightly janky up close, but if you back up a bit, it looks pretty good. The other thing that I can show you outside here is what they colloquially in video games call God rays, which is these lovely light rays that pass through the trees. This is something I've known how to enable since I started this project, but because of the way I had the lighting system set up, it just never looked right. It was either too bright or virtually invisible. But thanks to the auto exposure system that I've got set up and working now, it's looking pretty decent. So yeah, the garden is looking quite lush. Bushes everywhere. There's the trees around the outskirts of the property. Okay, let's go inside. The second thing is my light leakage issues are almost completely gone. I'm very, very happy about this. Speaking of the God rays, look at that, isn't it gorgeous? Oh, it's gorgeous. So if you look here, this is one of the problems I still have. When the sun is at certain angles, the ceiling will light up from this reflected sunlight over here and then darken as soon as you look up. But you'll see if I advance time a little bit, that problem more or less goes away. Haven't found a solution to that one yet. But if we switch a light on here and back out, you'll notice that that light leakage that used to happen around the bottom of the door is along the bottom of the door and the walls is completely gone. Very pleased about that. I had to change some settings in the way that shadows are generated according to the angle of the light, and that worked, but it also has some trade-offs. So if we go upstairs here and switch this light on, and then it's not doing it now. It's not doing it now, and I'm not sure why. Try switching this light on as well. No, okay, maybe it'll do it on the other flight of stairs. There's this weird shadow corruption thing that happens sometimes. There it is. If you look at the shadows along the shadows of the banisters essentially against the retaining wall there, you can see that jagged line. That's still a work in progress, but other than that, you can see my light leakage problem is almost completely gone. Very, very happy about that. The next thing is I'll have to go to the editor to really show you because it's random, so it's hard to... There. It would happen as I was talking. You might have heard a creak. The game now plays spooky sounds randomly according to an algorithm which I designed, in which all of the input values can be tweaked during runtime to adjust the frequency and chance that a spooky sound will play. But it's easier to show in the editor to show how that actually works, so we'll get there. The other thing is I've added a system whereby the lights can flicker, so you get this wonderfully spooky situation. I'll have to put an epilepsy warning on this video probably, and definitely on my finished game, because I don't want people freaking out and having seizures because of these flashing lights. Okay, the other thing is if we switch on a bunch of lights, and again this is algorithm based, there we go, based on an algorithm, the game will detect how many lights are switched on, and if how did I do it? It's going to be easier to show you in the editor. Oh, there's another spooky sound. going to be easier to show you in the editor. Let me just show you the last thing in here at full screen is I added that same functionality to the flashlight, which will obviously flicker independently of the main lights, but I don't have a sound effect for that yet, and that isn't algorithmic because I only want the flashlight to flicker when I, as the game designer, want it to flicker in certain scripted situations. Those are the main things that I wanted to show in this video, so let's jump across to the engine editor and I'll show you the code. Just while we're waiting for the editor to load, I wanted to show this as well. There's this thing called GDC, Game Development Conference, which has been running since 2015. And as part of the event every year, a company called Assonance.com give away game audio bundles. So bundles of sound effects every year from much larger sets. So you don't get everything in the bundle for free. Obviously you get a sample, but I've managed to collect all 6 of them here, and it comes to about 160 gigabytes in total, and they are just amazing sound effects. Like here's Camel Vocalizations. Which I think is quite creepy. I might actually use that in my game. Yeah, any sound you can think of, you can probably find at least a variation of in here. So that solved a lot of my sound problems. Okay, I will see you in the editor. And we're back in the editor. Okay, let's have a look at some code. This stuff is quite complicated, so if I end up stumbling over my words and getting overexcited, please forgive me. That does happen from time to time. Okay, let's start with the creepy sounds. And you can see I've left myself a little note here to do with an infinite loop that can be created under certain circumstances here. But yeah, on event begin play, we run a branch which checks to see if creepy house sounds are enabled. I just put a master switch in there because I wanted to be able to switch it off. We then get a random number between 1 and 10 and multiply it by this number here, which is a multiplier. So we're multiplying it by 5 in this case. So that is a number between 5 and 50 essentially, in increments of 5 obviously. We then delay for that period of time. Once the delay is over, we get another random number, and again we have a multiplier, and the multiplier here is also a 5, which means there's a just slightly better than 50% chance that the sound will play. We check it. If all these conditions are met, we then check to make sure the player is actually in the main house. I don't want the creepy sounds playing anywhere except in the main house, at least at this point. And then we play the creepy sound. I'll take you to that code in a second, but you'll notice we restart the loop. Yeah, now I've got this running off an event begin play, which only triggers once at the beginning of play, which is why I need to create a closed loop. And the reason I've done it like this instead of just running it off an event tick is because I think, at least to my little brain, it makes sense that this would be more efficient than having it check every frame. And also, we're doing the delay first for that exact reason. We're getting a random number and we're delaying by that amount of time. And the reason we're doing the delay first is because then all of this code only executes after the delay. So we're only running this code every 5 to 50 seconds, checking to see if the random chance is met and then playing the sound. Here's the code that plays the sound. Now what's interesting about this is how I determine where the sound is going to be. Firstly, we get 2 random numbers based on a minimum and a maximum, which I've set here in these 2 variables, between 1500 and 2500 units, which is between 15 and 25 meters essentially. We get random numbers for those and we set them as X and Y. We then do a true or false random to see if we're going to add or subtract that number to or from the player's position. We do the same for Y, and we set that as the final sound location. And once we have that, we either add or subtract, depending on the maths that was done before, these coordinates to or from the player's position, which gives us a between 15 and 25 meter radius around the player where a sound can play. Now, I'm not including the Z coordinate. You can see the Z coordinate stays the same, and the reason for that is I don't think the way that I'm going to be mixing sound in this game, I don't think you'll be able to tell if a sound is above or below you. So we haven't worried about that. And then we play the sound, and then again we restart the loop. And that's how the creepy sounds were done. So if we open the creepy sound queue, you can see here's all of the creepy sounds. I can give you a little sample of what I've got here. Just a random assortment of creaks, clatters, and thuds. The other interesting thing that I've done is here under attenuation, I have defined an inner and outer radius of how close you are to the sound, and I've set a low pass filter based on visibility. Now, visibility is not going to matter here, so the low pass filter is almost always going to apply unless the sound is very, very close to you in the same room. And this just muffles the sound. So we're cutting everything above 800 hertz off, so it sounds muffled like it's happening elsewhere in the house, which is exactly what we wanted. And that is the creepy sound effect system that I have designed. And now we'll look at the next one, which is the light flickering. Okay, so we'll start in an actual lighting blueprint. This is the first floor bathroom, and the reason we're doing that is because all of this code required me to change every single one of my 28 or so lighting blueprints, which was I mean, a day and a half of work, mainly just cutting and pasting, but it still took an insane level of concentration not to make any mistakes. But you know what, it's done now. So if we look at this on begin play, in every single lighting blueprint we have all of these references that we have to create, and now we have a new thing we need to create, which is setting the intensity of the light as a variable. This is just how bright the light is. In this case it's 250. So all we're doing at begin play is we're getting that value and setting it as a variable. This just makes it easier to copy and paste this code into other lighting blueprints in the future. Then the rest of the code, this is the code that makes the interact message appear, this is the code that makes the interact message disappear, this is the code that runs when you switch the light on, and then we get to this, the mains power control. Now what I did to make the lights flicker is just tied into the mains power control event dispatcher. And all that happens is we're calling this event dispatcher here, and we're calling it, I'll show you in a minute, from the player blueprint. And initially what this did was it just generated a power failure, so it would find all of the lights that were on and switch them off. But now we're tying in several other things, and there's one of these things I realize now I haven't even shown you yet. So we're checking these three variables here before we do anything else. Individual light address, which I forgot to show you, which I can actually show you right now. If I zoom out, you can see how much code there is in here now, which makes finding stuff a little bit tricky. This is to test this. Let's just make this living room, and we'll save it like that. And now if I push play, and go inside, pardon the sudden jerkiness, it's because we're back in the editor now, not running from a build. Switch this light on, and let's switch the living room light on. But the thing is, so if we generate a power failure and then put the power back on, you'll see we get a little flicker. Now, I'm actually not sure why that flicker is there. I need to go and check the code. I thought I coded it so that the flicker would only happen if more than a certain amount of lights on. That we'll get into that. But the point of this is I now have control. It's starting to get creepy up in here. I now have control over every individual light in the game from the player blueprint in runtime. All I need to do is enter in the name of the light, and I can address it individually using the same mechanic as I'm using to switch all the lights off with the power failure. So let's go back to the code. That was the point of that. So you can see here, test individual light addressing, and if we go back to the lighting blueprint, there's now a variable in here called light name. In this case, it's first floor bathroom. I had it set to living room now just for testing purposes. Okay, so back to the code. What we're doing here is we're first checking, is this call of this event to address an individual light? And the way we do that is, if we go back to the first person player, we just set a flag here, individual light addressed, before we do one of these, and then switch it off again. That way all of the code connected to the event dispatcher knows what the event dispatcher is for in that particular case. So let's go back here. Then we check, are the lights flickering? And again, I've got a Boolean set up for the game to check whether that is the case. If none of those are the case, we check to see if the mains power is on. If the mains power is on, we switch it off. If the mains power is off, we switch it on. So that part of the code was already there. These ones have been changed now. So if we go to individual light addressed, you'll see all we're doing is we're getting the name that's set in the player blueprint as the light we want to control, and we're comparing it against the name of this light, and if they're equal to each other, we just tie into the code that switches the light off or on, depending on whether the light is on or off. And then the final one is, are the lights flickering? And if they are, we run this code over here. And this code, okay, this is where it gets a little bit complicated, so bear with me. We start by checking, is the light on? If the light is not on, obviously we don't want it to flicker. And then we have another variable called light flickering state on. In other words, during this light flickering event, in what state is the light? Is it on or off? Obviously this is different from is light on. So we're checking that. If the light flickering state is on, we're going to turn it off, and if the light flickering state is off, we're going to turn it on. Now when I say off and on, I don't necessarily mean off and on. What we're doing is we're dimming it, which is why we have this value here that I showed you earlier, light intensity, now in every single blueprint. So what we're doing is we have, again, a random number chosen between two values here, which the flicker dimmer min value and flicker dimmer max value, which are set to 2 and 5 respectively at this point, and we're retrieving these from the player blueprint. And we're getting that random number, then we're dividing the light intensity by the result of that random number, and for a dim, when we're dimming the lights, we're setting the light to that intensity, and when we brighten the lights again, we're setting them back to their original intensity. And there's another variable here called flicker loop finished, which, I mean, I'm not even sure I can explain that, but it was tricky. I'll give it a go though. And again, once we've finished the loop, we tie back in. The reason we have to tie back in once the flicker loop is finished is because of an interesting thing that I discovered. So here is the code that actually makes the flickering happen. Firstly, we check if the mains power is on. Then we check if any lights on. If the number of lights on is equal to 0, we do nothing. Then we check, are the lights already flickering? Because if they are, we don't want to trigger another flickering event. If they're not, we set flickering to on and we begin the loop. And here again, we're getting a random number between 5 and 15, and that is how many times the light is going to flicker on and off. Then we check to see, is the player in the main house, garden, shed, or cottage, which are at this point the only places I want these flickering events to kind of have an effect. And if they are in those places, we play the sound. If they're not in those places, we still flicker the lights, but we don't play the sound. You can see here, if this Boolean is false, we skip past the bit that plays the sound. Now, I haven't really played this sound. I'm not a, well, I mean, you heard it in game, but just to refresh your memory, I'm not 100% happy with it. But there is a whole chunk of code. I use meta-sound for this, just because I can essentially trigger and stop it like really easily like this. It sounds like this. Yeah, but like I said, this will only play if we're in the main house, the garden shed, or the cottage. The lights will still flicker if you're not in those places. It actually looks quite creepy at night to see the lights flickering from outside the house, but obviously you don't want to hear that sound. Not 100% happy with the sound. I want something that's got more of a sort of AC kind of hum to it. That's, you know, sounds a bit bigger, but we'll get there. Mains power, yeah, okay, so here, this mains power is essentially starting the flicker loop. So all it's doing is it's calling this event dispatcher, and then this event dispatcher is going, okay, the lights are flickering, and then it goes to this code and it runs this code. We then set light flickering state on to false, which means that the next bit of code in the lighting blueprint runs according to that. You can see here we're checking for that variable. We then delay for a random amount of time between 100th and 1/10th of a second. And then we reverse the light flicker and we set lights flickering back to on, and we delay for the same amount of time. We then check to see if the flicker loop is finished, and I'll get to this in a second. If it's not, we check these two variables here. Every time we complete one round of flickering, we add one, we append this value here, and we then check it against that random number between 5 and 15 that we picked earlier. If they're equal to each other, we set flicker loop finished, and then we run the loop again. Now, why would we do that? The reason for that is because of the linear way that computers run code. If I have to go in here, I can show you exactly what I'm talking about. If we switch two lights on, you'll notice they run slightly out of phase with each other when they're flickering. So let's get in here so you can see both lights. You'll see they're slightly out of phase with each other because of the way the code works. Essentially, if more than one light is running, one of them will always end in an on state and one of them will always end in an off state. And obviously we don't want that to happen. We want the final state of the flicker to have all of the lights be in an on state. So what we do to solve that is we have this extra variable called flicker loop finished, and then we run the loop again. By having this variable and this check here, we're essentially making sure that any lights that end in an off state run through the cycle one more time so that they end up on. And once that code is finished, if the audio is still playing, we stop it, and then we reset all of the variables. Lights flickering is off, light flickering state is set back to on, the flicker counter is set to 0, and flicker loop finished is set to false. And that is how I solved a bunch of problems. Then in addition to all of that, we have the code that makes this happen randomly. Now, I need to update my comment here because I've changed all of this code. I'm not going to go into too much detail. It's more maths basically. But what this does is, oh no, I have updated this. So what this does is, every 20 to 40 seconds, there's a 50% chance for the lights to flicker if more than a third of the maximum desired lights are on. At this point, maximum desired lights on is set to 12. So if more than 4 lights are on, there's a 50% chance for the lights to flicker every 20 to 40 seconds. If more than 8 of the lights are on, so more than 2/3 of the lights, there is a 100% chance for the lights to flicker every 10 to 30 seconds. And this just does that algorithmic calculation and then runs the flicker event. There is one more thing that I wanted to show you. Okay, very briefly, this code checks to see how many lights are on, and if more than the hard number of lights to trigger power failure are on, the power will trip. The problem with this this code from the beginning was, it was then impossible to switch the power back on. So what I had to do was add 1 to the hard number of lights to trigger a power failure. So if it's set to 12, now all of a sudden it's set to 13. If the power trips again, it's set to 14. So I had to find a way to encourage the player to fix that problem. So what we do is we've got all of that flickering, and an event that happens in game, which I will show you in a minute, is that if you manage to trigger a power failure, the game will encourage you to switch some lights off, and the lights will continue flickering quite a lot until you start switching lights off. So because the hard number of lights to trigger power failure keeps going up, we have this new variable called desired number of lights to trigger power failure. So at the point where the number of lights that are actually on is less than or equal to 1 less than the desired number of lights to trigger a power failure, we then set the hard number of lights to trigger a power failure to equal the desired number. And so it gets reset. So instead of having that number that slowly climbs, as you switch lights off, the hard limit will reset itself once you've switched enough lights off. Sorry, I know that's complicated as hell, but that's how that works. And I can show you that in action. But first we're going to change these 2 values, because I don't want to have to spend ages walking around the house switching lights on. So let's set it to, let's say 43. Let's set it to 4. Let's set them both to 4, and we will compile and save, and I will push play. I'll give it a second. I'll leave the sun just below the horizon so it's nice and spooky in the house. So according to the maths that we do, as soon as we have more than 2 lights on, we should start seeing flickering. As soon as we have more than 3 lights on, we should start seeing lots of flickering, which is the game's way of warning you that the power grid is overloaded. This mechanic is going to feature in the final game based on communications you will get from the owner of the house warning you about this exactly. There we go. If we switch another light on, the power is going to trip. There it goes. Thankfully we have a flashlight. Now we will have to go down into the basement. So let's do that. You'll also notice the basement has been made very creepy indeed. I've subdivided it. I will be making doors to the left and to the right later, but at the moment it's just this creepy ass corridor. Now what happens is when you switch the mains on, there'll be a pause. Lights will flicker and the game will warn you that you should turn some lights off. Because if, well, there's another creepy sound, because if we turn another light on now, the lights will just trip again. So let's do that. There they go. Now we'll have to go back down into the basement and trigger them. And switch the power back on. You can see the lights are going boss, as they say in my native country. Okay, we better switch some lights off then. And as we start switching lights off, so the frequency of the buzzing and crackling and flickering will go down. Yeah, so that's it. That's what I've done with myself last week. You'll see there is still a certain amount of flickering, and that's just because we have the desired number of lights set so low that the algorithmic calculation is going to return a flickering state if more than one light is switched on. But yeah, that's I think all I have to show in this video. Sorry if it got a bit dense, and I will speak to you soon. Don't forget to like and subscribe.